Good morning everyone. So recall that in the last class we were discussing second order homogeneous differential equation with constant coefficient, which means how do we solve the differential equation of the form y double dash plus py dash plus qy is equal to 0 where p and q are constants. Now we will see a very special form of the differential equation which is known as the Euler equidimensional equation, which looks like x square y double dash plus pxy dash plus qy is equal to 0 where p and q are constants. This equation is known as Euler equidimensional equation, and we need to transform it into an equation with constant coefficient by substituting x is equal to e raised to the power x. You may ask why x is equal to e raised to the power x. That we will discuss in the next class, where we will transform any general equation into an equation with constant coefficient. So to transform it, I need y dash, which is dy by dx, which can be written as dy by dz and dz by dx. Here z is equal to log x, so this becomes 1 by x dy by dz. Similarly, y double dash would be d by dx of 1 by x dy by dz, which is minus 1 by x square dy by dz plus 1 by x d by dx of dy by dz. So I am simply using the chain rule. If I simplify it further, then it becomes minus 1 by x square dy by dz plus 1 by x d by dz of dy by dz multiplied by dz by dx, which is minus 1 by x square dy by dz plus 1 by x square d2y by dz square. So if I call them equation 2 and equation 3, then from equation 2, x of y dash is dy by dz, and from equation, so this is from equation 2, and from equation 3, x square y double dash becomes d2y by dz square minus dy by dz. Putting these two values into equation 1, which is x square y double dash plus pxy dash plus qy is equal to 0, implies x square y double dash is now d2y by dz square minus dy by dz plus p times dy by dz, which is xy dash plus qy is equal to 0. It means that the given equation get transformed into an equation with constant coefficient, which looks like d2y by dz square plus p minus 1 dy by dz plus qy is equal to 0. So this means that if you can recognize that the given equation is an Euler equidimensional equation, then you can directly transform it. You will say that by substituting x is equal to e raised to the power z, it get transformed into this form, and then we know that how to solve the equation with constant coefficients. So moving further, let's try a question. So it is x square y double dash plus 3xy dash plus 10y is equal to 0. So let's assume that we want to solve this question. Now it is clear in Euler equidimensional equation where p is equal to 3 and q is equal to 10. So it get transformed into d2y by dz square plus p minus 1, so which is 2 dy by dz plus 10y is equal to 0. Yes, by substituting z is equal to log x or x is equal to e raised to the power z. Now we know that how to solve the equation with constant coefficient. So the auxiliary equation is m square plus 2m plus 10 is equal to 0. So roots comes out to be, please do try by yourself, minus 1 plus minus 3i, which means the general solution is e raised to the power a z now. So minus x minus z, sorry, c1 cos bz, so c1 cos 3z plus c2 sin 3z, which can be written as e raised to the power minus log x, which is 1 by x, c1 cos 3 log x plus c2 sin 3 log x. So this is how we solve the Euler equidimensional equation. Similarly, let's quickly try one more question. X square y double dash minus 6y is equal to 0. Please solve it by yourself. If you solve it, you will observe here is that p is equal to 0 and q is equal to minus 6. So p is equal to 0 and q is equal to minus 6. Now if you substitute the values, then it will become d2y by dz square plus 0 minus 1, which is minus dy by dz minus 6y is equal to 0. Yes, so again it becomes an equation with constant coefficient by substituting z is equal to log x. Now the auxiliary equation is m square minus m minus 6 is equal to 0. If you solve it, then roots comes out to be minus 2 comma 3, which means y g is c1 e raised to the power minus 2z plus c2 e raised to the power 3z, which is c1 by x square plus c2 x cube when you substitute z is equal to log x. So you can see that if you manage to identify that it is an Euler equidimensional equation, then it is very easy to solve the given equation by transforming it into an equation with constant coefficient. Thank you very much.